Hello, everyone. Welcome to my new series. I'm going to be working on the LeetCode Blind 75 questions, which are the pretty much the top 75 questions that companies like to ask in their technical interviews. So I'll just basically just be going over some of those problems and going over the solutions, the runtime analysis. I'll be doing the solutions in both Java and Python, so I'll give you a Java solution first and then a Python solution. And I'll be going in depth about the data structures as well, how they work, and how you can use them in these various problems. So the first problem here is contains duplicate, which is an array problem. So right here, given an integer array called nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So here we have in our examples, we have this example array that we're passing in. It contains 1, 2, 3, and 1. And you can see that 1 is here twice. There's a duplicate, so we should output true. And then in this one, we can see that there are no repeats. They're all different numbers, so we would output false. So the first thing that we want to do here, well, first I should go over, a basic intro for the arrays. Right here, I just kind of have a Geek for Geeks open to kind of just explain the concept. So an array is basically like a list where you store your data in contiguous memory. So it goes like in a sequence. And then each slot has an index associated with that. So you can reference any spot in the array as long as you have the index. So if I wanted to get this A right here, then I would need the index for that. And I could just get that value right away if I know what the index is. And then your size of the array is declared, right when you're creating it or instantiating it. And, that's basically it for what you need to know about arrays. So let's go ahead and go into the problem here. So the best way to do this is to use a data structure called a hash set. And so right here I have the Java documentation open. Just to kind of show you. So a set is a collection that contains no duplicate elements, so it's basically like a list, but you can't have any repeats in it. More formally, sets contain no pair of elements E1 and E2, such that E1 equals E2. And these documentations are pretty nice because it tells you what they are, and it also gives you like all the methods that are available for that collection. So you can see right here we have an add all, clear. We can check if it contains something, if it's empty. We can also remove as well, or split it into an array if we need to. Then you have all the details for each of the methods right here. So let's go ahead and start writing up a solution right here. So first off, we're obviously going to want to iterate throughout the entire array because we need to check at least each element once to see if it's a duplicate or not. So we're going to go ahead and start a loop right here. Okay, so first we start off with an index at 0, which is going to be the first element of the array that's being passed in. And then we're going to keep looping until we reach the nums.length. So this is going to pass over every element of the array. And so now what we want to do is inside the loop, for every iteration, we're going to want to check if, well, actually, sorry, first we should create the set. I forgot to do that. Okay, so we have our set right now. And so now, inside the loop, every time we iterate, we're going to want to check if that set contains the element that we are currently on. And if it does, then we can return true. So right here, for every element that's in our array, we're checking if in our set it's already in there or not. And if it is, then that would show that we have a duplicate because we've already seen it before. But if it is not already in there, then we just want to add it into our set. We want to add the current element into the set, which is going to be nums at index I. And as you remember, like I said earlier, the set only contains distinct elements, so you will not be able to add duplicate elements or anything like that. This will always only add new elements. Okay, and then if we go through that entire loop and don't come up with any duplicates, then we can just return false to show that whatever array was passed in is completely distinct. Okay, let's go ahead and try running this, or submitting it. Let's see here, I think I have a if set.contains. What am I forgetting right here? Set.contains. Oh, I see. I accidentally put brackets right here. Should be like that. There we go. It's going to be one more. There we go. Let's see. Maybe if I try running code first. Okay, give me a compiler. It's called nums is the array. I accidentally put num. Those syntax errors could definitely take some time. Okay, there we go. So you can see right here, runtime was only 22 milliseconds. So the runtime analysis for this, this runs in time complexity of order of n, and that's because we're having to go through the entire array. We're only passing through it once, and that's evident by only the one loop right here. So you can see this is order of n. So however many elements we have in the array is how many elements we're going to be checking, essentially, in our loop. And that is the best possible solution that you could hope for right here. At minimum, you do have to check every single element to ensure that there's no duplicates, so you can't get any better than O of n. Okay, so now that we have that, oh, and the space complexity is just order of n for our hash set right here. We're only storing unique elements, and that will be at worst order of n. So if every element is distinct, then we would just be adding n elements into our set. So it would be the same size as the array that's getting passed in. So space complexity would also be order of n. Okay, so now let's go ahead and do a Python solution now. Python 3. And so it's going to be kind of a similar idea right here, just a different data type right here. So in Python, we're going to be using a dictionary. And I have here the Python documentation. You can see right here, dictionary. This is basically the equivalent to the hash map in Java, where you have a key and a value pair as your elements in the dictionary. So every key is unique in the dictionary, and then you can have any value you want associated with that key. You can't have any duplicate keys. So it's pretty similar to the set in that way. And as you can see right here, you can have the key be, a variety of different data types. You can have it be an int or a string or whatever. And then the value can also be pretty much anything you want. It's written like this, so you have the key right here, Jack, and then the value associated with that is 4098. So anytime you want to get this value, you can just reference the key right here, and that will return the value that's associated with that key. So let's go ahead and try implementing that. So let's go ahead and create a dictionary first. So let's call it counts. And that's the syntax right here. It's these curly braces. That's how you create a dictionary. Okay, so we have counts. Why is it red? Let me see here. Counts equals. Okay, there we go. It's probably just some indenting problem. Okay, and then we're going to also want to do another loop right here. So for I in nums. This is how the loops are done in Python. It's basically like a for each loop, where instead of using the index, we're just taking the value right here in the array. So we have the list of numbers, and then I representing the number that we're currently on in the array. So it's the actual element instead of the index. And so now we're going to want to do counts I equals count.get I 0 plus 1. And let me see right here. Does it say? I'll just show you guys if it's here. It might not be. We can just look it up on another thing. Dictionary get. I want to show you guys what this does. Actually, this will be better, I think. Okay, so we have a get function or method that we can use with the dictionary. And so what the get does is returns the value for the specified key if the key is in the dictionary. So you can see right here, marks as a dictionary, and then we're getting the key physics, and that would give us the value. This is just kind of a more formal way of getting the, right here, it's pretty much the equivalent of this. So what we're doing right here is for every element, or for every spot in our dictionary, for every pair, we're going to be getting the number that we're at. So we pass in a key and then a value. Takes a key and a value. So we're getting a key and then the value plus 1. And so what this is basically doing right here is we're looping through the list and we're storing the count of every num that we see in the dictionary. So for example, if we come across a 1, then we're going to put that into our dictionary. And then if we see it, we're going to store that we've seen it once, which is what counts.get plus 1 right here. So we start at 0 for that specific number, and then we add 1 onto it. And then if we run into it again, then we're going to get it, and then it's going to add 1 to it, whatever the occurrences is. So the 1 right here would be 2. So we would have a key of 1, and then the occurrences would be 2. So that's what we're doing right here. Okay, and so now we have a dictionary that's filled with the keys for all the numbers in the array, and then the occurrences as well. So we're going to want to loop through that dictionary. Let me just go ahead and do this. Counts.items. If count is greater than 1, then return true. Okay, and let me go ahead and actually show you guys what items does as well. Right here. Okay, so the items method will return a view object that displays a list of all the dictionary's keys and values in a tuple pair. So you can see right here, we're calling items, and then the output is going to give us kind of like a view with all the pairs that we have right here. So we have the key right here and then a value right here, and we have that for all the pairs that are in that dictionary. And so for right here, we're going through all of the things we have in our dictionary. So for num, which is going to be our key, and then the count, which is the value. So we're going through all that in the counts of items. And then if we find any count that's greater than 1, then we know that a number has been repeated. So we would return true in that case. So let me see if this works. We might have to return false though. Okay, it worked. And runtime for this is similarly O of n. As you can see, even though we have two different loops right here, they're not nested within each other. They're separate loops. So that would effectively be O of 2n, which just gets reduced to O of n. And of course, the reason why for that is we have to loop through all the elements at least once. So we're making one pass right here and then one pass right here. But they're separately done. So it'd be order of n. Space complexity is also just order of n. Counts is pretty much acting the same as the set we had in our Java problem. Okay, so that pretty much does it for this problem. You can see it's not too hard. Actually, should I do any other language? So Java and Python are the ones that I know the best. But maybe I should do another one. Try to think here. Yeah, I'll do a C++ as well. Okay, so let's see if I can remember the syntax for C++. Haven't used it in a while. But I know a lot of people like to use it for interviews, so we can use a map for this. Let's try a map. I think it's something like this. And let me actually see if C++ map. This is the correct documentation. Okay, yes. So we have map as a sorted associative container that contains key value pairs. Let's see here. A lot of different information right here. Yeah, you can see all the different kinds of methods we have here. Let's see. So just want to declare a map right here. We're saying that the type of the key is going to be an int, and then the type of the value is also going to be an int. So let's go ahead and do another loop through all the elements. We'll do for int n in nums. This is the for each loop. It's similar to how the one in Python is, just a little bit different semantically or syntactically. So instead of using indexes, we're using the actual element, as you can see right here, going through the actual elements. So we can do map, whatever we're at, whatever element we're on, plus plus. And so this is going to get the key, and then whatever the value is, we're going to increment it by 1, since the value is also type int. That's why we're able to do a plus plus to it right here. And then if map, actually I should probably not use the same term right here, since that's what it's called right here. We'll call it m. Let's do m, yeah. And we're going to check if that is greater than 1, in which case we return true. Otherwise, we'll just return false. Okay, and yeah, this is pretty much doing the same concept as before. We're checking if the value, or the key that we're on, we're checking if its occurrences is greater than 1, similar to how we did in Python. So for example right here, if m of n was at this 1 right here, and we're checking its value right here, if it's greater than 1, so this would have a value of 2 since 1 has been encountered twice, so it would have incremented it twice up here. So when it runs the check right here, if the occurrences is greater than 1, it'll return true. Whereas in this one right here, every element is distinct, so this would only get incremented once for each of these elements. So when you're checking each of those elements' occurrences, all of them will be equal to 1, so this won't return true. Let's try submitting this, see if it works. Okay, let's see. Syntax errors always get me. Expected expression. If m of n I see. Put the parenthesis too soon right there. Closed it off too early. Okay. There you go. So, same thing as the other solutions. It's order of n for time and space complexity. So I hope you get the idea with this problem. It's pretty simple. You just need to use the some kind of instance of a map or a set or something where you can store the counts of each of these while only having to pass through it once. Now, there probably is a solution where you can, the brute force solution, where you can just do a nested loop where you're starting out at each element right here, and then you're going on and checking if any of these are equal to the element that you're currently on. But that would, a nested loop solution like that would give you order of n squared, which would not be good. That would be very slow for very large inputs. Every time you increase the size of this, your runtime would increase quadratically. So, but yeah, I think that's pretty much everything. So I hope you guys enjoyed this video. We covered the contains duplicate problem right here. And I will see you guys in the next video, that I'll be tackling, which I believe will be the reversed linked list problem. Um, Hopefully my solutions made sense to you guys. And thank you for watching. I'll see you guys next time. Bye.